Okay, so we start off with segment addition postulate. Segment addition is kind of what the name says. We've got segments that are added together. So let me draw just a little picture here. So I've got a line segment, but then there's another point in the middle. It's between them. So here's what segment addition postulate says. So we've got segment AB, and if we talked yesterday about putting the line segment above it, but when we're actually talking about how long it is, like let's say it's 5 inches, if we're talking about the length itself rather than just the segment, we don't put a line segment above it. So I'm going to leave it just as AB. That means I'm talking about how long that is. If I take that distance and I add to it the distance from B to C, what will I have in total? So the distance from A to B plus the distance from B to C gives me the full length, the full thing all the way from A to C. So we get AC. And so that's all the segment addition postulate says. AB plus BC equals AC. So let's take a look at this picture of South Dakota. They've got a straight line segment there. It says from Dixon to Bismarck is 99 miles, or Dickinson to Bismarck. If you go from Dickinson all the way to Fargo, you go to 289 miles. So the question is, how far is it to get from Bismarck to Fargo? Well, what we know from the segment addition postulate is that from Dickinson to Bismarck, which is 99 miles, if you take that and add to it the distance from Bismarck to Fargo, which I don't know, that's what I'm trying to find, maybe I'll call it X, it will equal the total distance, which we know is 289. So we can write this equation, 99 plus X is equal to 289. We subtract the 99 and I get my answer. So 190 miles. So then we look at question number 2. We see several numbers from P to R we see is 55. From Q to R is 31. From R to S is 30. They want us in part A to find the length from Q to S. So if we start at Q and we work our way to S, we have to pass through R. So from Q to R is 31. But then from R to S is another 30. So we have to add 31 and 30, giving us the total of 61. If it says find PQ, well, that's part of the 55 segment, but it's not the whole thing. So what we have is, from P to Q is something, plus Q to R is 31, and when we add those two things together, we get the total of 55, that spanned the whole 55. And now we can use subtraction to solve for PQ. So we get 24. Okay, and then it gives us a spot to define congruent segments. Congruent segments are just segments that have the same length. I'm going to draw two segments. We'll call this first one AB. I'm going to draw one below it. I'm going to try to have it about the same length. We'll call it CD. So if I know the number, if I know like that they're both 5, for example, then I would know that they're congruent. Sometimes we mark with a little symbol, just a little dash right on the segment, kind of in between A and B. We just do a little perpendicular dash, and we do the same thing on CD. If I have a single dash on both of them, that's my way of showing that the two segments are congruent without having to know the number, how long it is. That shows that they're congruent. So here's how we write or express in a statement that they're congruent. So segment AB, and here I'm talking about the segment, I'm not talking about how long it is, so I put the segment mark above it, is congruent. Here's your congruent symbol. It starts off like an equal sign, but then we put this little like tilde above it, basically, or a little squiggle above it. And then it's congruent to segment CD. So that's how we can write that two segments are congruent. When we get to question number 3, we're supposed to graph these points. I'm going to use a Sharpie so it's a little easier to see. I'm going to go from negative 2, negative 5. Maybe it's been a while since you've plotted any points. The first number, the x number, is left-right. So it's a directional left-right. We have to go negative 2, so that's 2 to the left. And then the y value is up-down, and it was negative 5, so I had to go down 5. So I went 2 to the left, down 5, that's point x. Then I also have to graph y, which is negative 2, 3. Negative 2, and then a positive 3. So 2 to the left, and then up 3. And then w is negative 4. 3. Maybe I should have moved my letters here. Sorry, that got a little messy. And z is 4, 3. Let's see. Positive 4. 4 to the right. Up 3. Okay, so the question now is our segment xy. So let's draw in xy. I'm just going to connect x to y. Our segment xy, and then segment wz. So start at w and go through z. Says, are they congruent? Well, since they're not diagonal, they're just horizontal and vertical, I can just count how long the segment is. So let's count from x to y. So I'll start down at x and I'll count up. So 1, 2, 3, 4, 5, 6, 7, 8 units. xy is 8 units. I'm talking about its length, so I don't put the segment line above it. So I can just say xy equals 8, so I can mark that down. Now let's see what wz is. How long is it? 1, 2, 3, 4, 5, 6, 7, 8. Also, they both have the same length, therefore they're congruent. So we can just answer the question, yes. Let's flip up to the back page. These problems here are what I would like for you to finish up on your own as just the rest of the assignment from this section. Okay, so that's the end of